Move on to the another question. MSB safety, this is the safety part, I will explain later. Grounding of a bus bar. Okay, grounding of a bus bar. So how you do the grounding and why we need the grounding? Basically there are the another terms are also there: grounding, earthing and bonding. Okay, grounding, earthing and bonding. So these are the different purpose, they are using for different purpose. Grounding, why we are doing the grounding, why we are doing the earthing, I will explain in a separate lecture also, because this is a long topic. Grounding we are using basically in a live conductor. Okay, suppose the generator having the neutral point, and then we ground this generator with the help of neutral earthing resistance. We are doing the grounding, because if any fault current will be there, it will directly ground it. Okay, another thing we are using in a non-metallic enclosure, like suppose your motor is there, and your motor having the enclosure which having non current carrying, because the motor don't carry any current. This motor enclosure don't carry any current, and we do the earthing from the motor enclosure to the ship hull. Okay, so why we are doing? To protect the, if there is any fault in a motor, and due to this if somebody directly touch this, maybe get a shock, so we have to proper ground this fault current. Okay, so we just connect with the motor enclosure to the ground. So we are doing this earthing. And bonding, basically we are doing to maintain the equipotential. Suppose there is a two motor, and this is connected with a 3-phase supply, and this is connected with a single phase supply. So there is a voltage difference is there, and due to this maybe potential difference will create, because let's suppose some wire will touch this motor, and due to this there will be potential difference created between these two motor, and somebody come and directly touch this and get a very heavy shock. So we have to maintain a potential balance. So equipotential, we have to maintain the potential at a same level. So we are just bonding the motor directly from metal to metal enclosure. We directly connect with a wire, we are doing the bonding. So this is the bonding. I think I already told everything here. So this is the bonding, earthing and your grounding I already explained. Okay, so now for bus bar, grounding is very necessary, because if some let's suppose there is some fault, and due to this too much fault, heavy fault current will be flow from a system or a bus bar. So if somebody is nearby getting a shock, so we have to properly ground the bus bar. Okay, so bus bar is a metallic strip where we basically use for the power distribution, because the cable are directly connected to the bus bar, and with the help of bus bar we are basically distribute the power to different load and proper load distribution. Okay, so grounding a bus bar is very important. I think you already explain, understand, don't need to explain further. So move on to the next question. Okay, why induction motor will not run as a synchronous speed? Okay, why induction motor not run as a synchronous speed? This is a very easy answer you can tell. I already explained you your synchronous motor, how the synchronous motor is working. Synchronous motor, first you give the motor 3-phase supply, then there is a rotating magnetic field on the stator. Okay, and due to this when it's cut this rotating magnetic field to the rotor, due to this EMF will be induced, and due to this current will be also induced, and due to this secondary magnetic field will induced. And when this secondary magnetic field just interact with the rotating magnetic field of the stator, then there is always a relative motion. What is relative motion? Let's suppose this rotating magnetic field having some speed, and this secondary magnetic field having some speed, and if there is some difference, some difference is there between the stator rotating magnetic field and rotor secondary magnetic field, there is some relative motion. Due to this a torque is generated, and this torque helps the induction motor to rotate. So if there is no relative motion, no torque will generate and motor will not run. So there will be always some relative motion between the rotor rotating magnetic field and stator rotating magnetic field. Due to this motor will rotate, and that is called a slip. Slip speed is basically termed as synchronous speed and rotor speed. Synchronous speed is the rotating magnetic field speed, and this rotor speed is the rotor speed. Okay, the difference between the synchronous and rotor is termed as a slip, and percentage of slip is difference in slip speed by synchronous speed. Slip speed by synchronous speed. Slip speed by synchronous speed. Synchronous speed. Okay, and this is the slip speed. So always there will be some relative motion. If there is no relative motion, there will be no induction motor will not rotate. So always relative motion is necessary. I already explained you. Move on to the another question. You can read this also. I think I already explained. But always we have to maintain this minimum slip. If you don't maintain this slip, your motor will not rotate. So how to convert AC and DC on board? What are the choices for converting AC to DC on board? What are the choices? Okay, what are the choices? So first of all, you can convert this AC to AC. Okay, AC to AC with the help of transformer, and with the help of AC to DC we are using the rectifiers. Okay, first how you can convert, if let's suppose the voltage is very high, voltage is, let's suppose voltage is 3.3 kV, you just convert this voltage into, you want 440 volt DC or whatever the voltage you want in the DC form. So this is the AC, you just convert this AC into 440 volt AC. Okay, 440 volt AC with the help of transformer, and this AC we are, with the help of rectifier we are converting into the DC, that is 440 volt DC. So we can do like this also. So with the help of transformer, rectifier, and there is a filter for smoothen the voltage, because there is some ripples is there, because when you convert in DC, this is not a proper DC, there is will be some ripple will be there. Okay, but when you pass through a capacitor, this is a capacitor, your voltage will be smoothen. Okay, your voltage will be smoothen like this. Okay, so we are using the filters also. Okay, and capacitor basically it is a type of filter, and voltage regulator maybe stabilizer for the maintaining the output voltage, and voltage regulation same. So you can do like this. Okay, so I already explained. Move on to the further another question. Classification society certificate, this is the safety part, I will explain later, but here a question is there, I will explain later, because now this is the electrical lecture, I will not going in the safety part. Okay, so moving on to the further question. This TXV valve. Okay, this TXV valve, okay, thermostatic expansion valve. I will explain in very simple. Thermostatic expansion valve is a type of valve. Okay, this is a type of valve where there is a very small hole and very small nozzle, and when the liquid refrigerant pass from here and due to this very small diameter, the liquid of a level is passing through a very small hole. Due to this there will be pressure drop, and due to this pressure drop, what will happen? Pressure will drop, then temperature will also drop. Pressure directly proportional to temperature. If pressure will be dropped, temperature will drop, and then your vapor, if let's suppose the liquid is coming from the compressor which is having the high pressure vapor is coming to the expansion valve, and expansion valve is passing this refrigerant via this TXV valve, and there is a very small hole, and depend upon the hole we are controlling the temperature, and based upon the filters also, because there are the number of the filter. When you open this, you will get 1 number, 2 number size filters are there, and the hole size is there, and based upon this hole size we are maintaining the temperature. Okay, for meat room, fish room, we are using different types of filters and nozzles for controlling the temperature. So we can maintain this temperature -18, 5 degree, whatever the temperature your requirement, it depend upon this nozzles. Okay, TXV nozzles. So basically the main purpose, it sends the temperature from the chamber. If the temperature is not according to the set point, then it open the valve, and then the refrigerant will start flowing from this TXV, and this TXV will reduce this pressure, and due to this reduced pressure, the high pressure, high temperature liquid will convert into the low pressure, low temperature liquid, which is basically in the liquid form, and when it going to the evaporator, it will directly vaporize, it will directly suck the atmosphere, which is the hot atmosphere, it directly suck the atmosphere at the evaporator, and then evaporator whenever the liquid going to the again suction side of the compressor will be in the vapor form, not in the liquid form. Okay, we have to must take care of this. Whatever the liquid is going to the compressor, it must have to superheated vapor form. Okay, superheated vapor form. So low pressure, low temperature, now enter to the evaporator. Now enter to the evaporator and suck all the hot atmosphere, and then it going to the compressor. This is the refrigeration cycle. I will explain you. So TSV, you explain, you understand. It basically sends the temperature. If the temperature is not according to the set point, not according to the set point, it will open the valve. It suppose your temperature is your temperature is 5 degrees Celsius, and now your chamber inside the temperature is 8 degrees Celsius, then there is 3 degrees Celsius difference is there. So what will happen, it will open the TSV valve, then refrigerant will start flow, and it will cool the temperature, cool the chamber, and decrease the temperature up to 3 degree difference, and then maintain the temperature inside the chamber. The main purpose of TXV, and how it do, with the help of these nozzles and different types of the filter arrangement is there. Okay, so you explain, you understand this thermostatic expansion valve. What is thermistor? Next question is, so what is thermistor? Okay, guys, what is thermistor? I will explain. Thermistor is nothing, basically thermistor is a type of resistor. I will explain. Thermistor is basically a type of resistor whose electrical resistance changes significantly with the temperature. Whatever I am talking, resistor, thermistor is a thermistor is a type of resistor which is directly proportional to the temperature. If temperature will increase, its resistance will increase. So if temperature will increase, its resistance will increase. That type of thermistor is known as positive temperature resistor, positive temperature coefficient thermistor. Okay, PTC type. And whenever there is increase in temperature and then resistance will decrease, so due to this, this is negative temperature coefficient thermistor, NTC type. Okay, there are two type of thermistor, and thermistor is basically a type of resistor whose electrical resistance changing significantly with the temperature. It is commonly used as a temperature sensor. Basically we are using for the temperature monitoring, temperature calibration, used as a temperature sensor or in a circuit for temperature control and compensation. Okay, you understand. There is NTC where negative temperature resistance decreases as the temperature increases. Okay, I already explained you the transducer. Transducer also just convert this temperature into a electrical signal. Here NTC also just convert this temperature in a basically with the help of resistance, it convert this resistance into an electrical signal, and then for process further in a temperature controller for the temperature monitoring system. Okay, so you explain, I explain you everything here. NTC and PTC, there are two type of thermistor, NTC and PTC, and temperature basically dependent. You know also this resistance directly proportional to temperature, resistance inversely proportional to temperature. This is NTC and this is PTC type. Okay, so this is the thermistor. I already explained. Droop I already explained you before also. What is speed droop? I already explained you before. No need to again and again tell same thing, because I already explained. If your load will increase, if load will increase, your speed will decrease. Adjust fuel supply, adjust fuel, it means increase fuel. Okay, so we have to increase fuel to maintain a constant voltage, maintain a constant voltage. Okay, basically the main purpose of the. And droop, basically you say, let's suppose some generator having 4% droop, 3% droop. What is the meaning of this droop? 4%, 3%. It means, let's suppose your generator rated RPM is 1500 and droop is 4%. Okay, is a droop is 4%. What the mean is this? If you just do the mathematical expression, you just do this some mathematics here. 1500 4% is 60. Then you just subtract this 1500 minus 60, you will get 414. It means at no load, your engine RPM will be 1500 RPM, and when you run this generator at a full load, your full load RPM will be 1460. It will drop 1440. It will drop up to 60 RPM from no load to full load. That is basically a droop. Okay, so you understand this very well. I already explained. You understand this one. So just read this one. Finish. So move on to the next. Droop I already explained. Different types of pressure sensors, flow sensors is there. Okay, what is the pressure sensors is there. Basically differential pressure transmitter is there. I will explain this in detail later. Basically what type of sensors are there are explained. Differential pressure flow sensor, how it's working. This sensor having a construction, it means there is a venturi tube is there, venturi tube. Inside this sensor there is a venturi tube which create a pressure difference, and measure this pressure difference at a incoming and outgoing point, and with the help of this pressure difference they are just controlling the levels. Okay, this sensor use a constriction orifice plate venturi tube in the flow part to create a pressure drop, and the difference is pressure before and after the constriction is measured and used to calculate the flow rate. Basically we are using to calculate the flow rate, and how we can calculate from the differential pressure transmitter. We are basically calculate the flow rate, and based upon that we are controlling the flow rate also. Okay, this is the differential pressure transmitter, DPT type. I will explain later also. Electromagnetic flow sensor, basically this is electromagnetic type, where is a there is a sensor wound with a coil, and it's placed on a substance which we want to measure anything like speed and another thing. Basically we are using in a speed log also. We are using this electromagnetic or Doppler shift type. I will explain in the bridge equipment also. So electromagnetic flow sensor is there. There is a wound of coil in a sensor, and when you place this in a sea water, and then water is continuously flowing, and due to this there is a magnetic field change, because this current is going from this sensor, it create a magnetic field, and when the speed of the water is continuously changing, due to this magnetic field will be changed, and change in magnetic field basically tell us about the speed of the ship. So main purpose of the electromagnetic flow sensor I already explained. So flows through a magnetic field generated by a sensor. Electrode detect the induced voltage which is proportional to the flow rate. Okay, so we are calculating in a speed also. This one, ultrasonic sensor is there. What ultrasonic sensor is there? Ultrasonic sensor, we are doing nothing, just transmit a sound wave, and reflect back. This sound wave having some frequency before transmitting, having 1600 frequency, and when reflect from the seabed, sea surface is there, it reflect, and then 1200 Hz frequency is there. Then difference is the frequency, then there is a difference in a frequency of sound wave, and how much time it will take to reflect from a surface, and from the time and this sound wave frequency we are basically calculate the speed. Okay, we are basically calculate the distance barabar speed into time. Okay, so you know the speed, you know the time, how much time it will take, and you can easily calculate the distance. What is the depth of the sea water or seabed, whatever. So basically ultrasonic sensor are using for that purpose. You can read here, this sensor can work on the either Doppler effect also, change in frequency also, sometime giving this depth also. Okay, and transmit time principle, difference of the sound wave traveling, and this I already explained. So these are the basically main three sensors we are using on board. Difference between electronic and power electronic I already explained you before also. Electronic deal with the low current, low power. Okay, and power electronic deal with the high power, high current and high voltage circuits. We are using thyristor, IGBTs, IGCTs, MOSFETs we are using in power electronics, and small diodes, transistors, small transistor we are using for the electronic semiconductor devices. So I already explained you this thing also. So move on to the further. Proportional controller I already explained you before also, and the proportional band, sometimes they are asking what is proportional band. So you read this one. Proportional band is a term in which the process control system to describe the range of the input signal values over which the proportional control respond. It means the proportional control will respond only to the range of some input. Some band is there, because band having some range, and within this band the proportional controller will act, and that range is basically termed as the proportional band. Okay, so this is the proportional band. I already explained, no need to explain again. Move on to the further. What is it under voltage strip? I said it will not let to close the ACB. Okay. So this is somebody tell before also. Some surveyor will ask this question. What is it under voltage strip? Okay, under voltage strip basically sense the under voltage of the generator. If the generator voltage will falls, let's suppose in our SIP vessel 85% of the voltage. Let's suppose your 440 volt is the full load voltage. This is the output voltage. But if 15% drop and voltage drop up to 85%, and this is the set point of the under voltage relay, and if the voltage comes 85% of the full load voltage for few seconds, let's 5 seconds, 8 seconds, then it will sense and give signal to the relay. It will trip the circuit and isolate the circuit from the bus bar. Okay, so under voltage relay having the main purpose of this, I already explained what is under voltage relay and how it's working. I already explained. There is a under voltage, we continuously monitor the bus bar voltage or generator voltage. If the voltage is just below the set point, let's suppose there is some set point is there, and if the voltage goes below from the set point, and setting is generally 85% of full load voltage. So if the voltage is going less than 85% for a few seconds, 85% of a full load voltage for a few seconds, then it gives signal to the relay, and relay will isolate the circuit and it will trip the breaker. Okay, so under voltage relay. And here is a question. I said it will not let to close the if the voltage is lower than 85%. Then he said before that one more important point, that is the what will happen if not close the more. If let's suppose your ACP is not closing, under voltage strip already happened, your voltage will be below the set point, but your ACP will not let to be open. So what will happen that time? Due to this, more and more current will flow and damage the winding. So this will happen. Okay, so you have to read this one. Okay, so move to the next question. If an under voltage strip occur but ACB fails to disconnect. Okay, I already told you, if ACB fails to disconnect, then there will be generator overloading, because current will increase, and if the current will increase, there will be more and more overheating and damage the generator and damage the prime mover and all other things also, and damage the another equipment, because the equipment which is connected from the generator, if the current will increase, their speed will also increase, and due to this motor will try to run faster, it will take the more and more current, so it will damage the connected equipment also. So okay, if the generator is connected to the other generator in parallel under voltage condition, one generator lead to the system instability. Okay, and what are the possible causes? What are the possible causes for the ACB falling to disconnect? Let's suppose why ACB not disconnect. What are the reason? Maybe surveyor will ask you also. There will be maybe mechanical fault, maybe some mechanism will stuck inside the breaker. We have to isolate the breaker and rack in the breaker, and we have to check everything. Then control circuit issue, maybe some under voltage relay is not working, it will not trip the circuit, because there will be loss of power in the under voltage, there is a control power failure. Then incorrect setting, maybe also the incorrect setting in the under voltage relay, so it will not trip the breaker. And some electrical loose connection, control power loose connection may be also there. So we have to check everything one by one. And first, how we can troubleshoot, we have to first check the alarm, which alarm is just comes before tripping the breaker, and according to that we have to troubleshoot. Why H2O is mixed, I already explained you, to maintain the electrolyte level, and why electrolyte level we are maintaining, I already explained, no need to explain anything. And why distilled water, I already explained, because of the impurities, because it contain minerals, so we are not using this mineral because it lead to the corrosion, reduce efficiency, or lead to the short circuit within the batteries. So I already explained you. Type of excitation system, there are the basically three type. DC excitation is there, and static excitation is there, static excitation is there, and rotatory excitation is there, rotatory excitation is there. Basically 3 type of excitation we are using in a generator. I will explain one by one in detail because this is the most important, and 100% surveyor will ask you this question most probably. So you have to worry about this, you have to prepare this. I will explain in a separate video. This is a long video, so I will not explain here. Difference in ampere because of the power factor difference of the alternator. Okay, if there is a difference in ampere of a generator, so what we have to do, because ampere difference, then power factor will be different, because the current and voltage there will be phase difference. Okay, so we have to AVR droop setting, because we have to adjust the AVR, because AVR is basically adjust the this current. AVR basically adjusts this current, field excitation current also AVR will adjust, and due to this our voltage will be maintained. So we have to maintain the AVR droop setting. Okay, condition for transistor to work as a voltage regulator and proper biasing. I already explained you in a transistor thin base bias system in just before some time. Okay, you just go some upward questions, you will get this answer. Condition for proper biasing of a transistor and act as a voltage regulator. Okay, so voltage regulator, it will act as a proper biasing. You have to do the proper biasing, and I already explained you emitter base junction must be in forward bias, and collector emitter junction must be in reverse bias, operating in Q point in between this there is a this is the cut-off point, this is the saturation point, and operate Q point in between middle of the saturation and cutoff. So proper biasing you have to do like this. Okay, so and then your transistor is work properly. So this is the question. Intrinsic safe equipment voltage and current rating. Okay, so next question is intrinsic safe equipment voltage and current rating. They are not asking about the intrinsic safe equipment. I already explained you intrinsic safe equipment for the hazardous area, and how we are protecting this intrinsic safe equipment from any explosion, and how we reduce the current and voltage with the help of the Zener diode barrier circuit. I already explained in my previous lecture. You go through there, you can easily understand. Now I just tell you the voltage and current rating for this intrinsic equipment. So voltage and current rating, we are basically uses 30 volt, and we are using in the voltage between 12 volt to 24 volt, and current ampere is 100 milliampere to 1.5 ampere. Very less current we are using, because it will not create any spark, and voltage we are also using very less, and power we are also limiting up to 1 watt to 2 watt, 1.3 watt to 2 watt, or 1 watt to 2 watt, whatever the power limit is also very less. Okay, so these are the basically current reading and all this. So next question is how you will find out which type of starter by looking on the motor. This is my last question for today lecture, and after that I will explain one by one later. I already explained so many questions now, and our next part will come very soon. So this is my last question for today video. So how will you find out which type of starter by looking at the motor? Suppose you have one motor, and you have a starter circuit for this motor, and you have to find out type of starter, which type of starter is connected to the motor. So how you can basically know about this? So first of all, you just look onto the motor also, sometime nameplate also showing which type of winding is needed for the motor, star or delta or some type of wiring, and you just look the starter unit, direct online starter having the very simple circuit, star delta having a timers and relays, and the star contactor, main contactor, and there is a short circuit between the three. We just sort the star and delta contactor. Star contactor we are just sort this 3 wire. So you just look the starters, and you can assume this is the dual or star delta. You can like this, because star delta we need one timer. Okay, we need one timer, and one star contactor, one main contactor, and one delta contactor also, and interlocking also there. So you can easily understand the star and delta. And star having the we are doing power winding, we just sort the terminal also. So you look this and you can find out which type of winding is there also by the help of number plate also, name plate also. And sometime of auto transformer is a very bulky and heavy component, you can easily find if there is a auto transformer is there. Soft starter basically electronic devices, you can easily understand soft starter. Okay, electronic component is there, thyristor, microcontroller is there. Okay, and no moving part inside the soft starter, and there is a bypass also. If soft starter you want to bypass, you can easily bypass. Variable frequency drive is there, variable which basically vary the frequency and voltage. Okay, it having the display panel basically used for the speed control, and with the help of wiring diagram you can also check. So okay, this is the last question for today's lecture, and from tomorrow I will again start taking some another oral questions. I have so many questions, and these are all asked questions. Okay, these are all asked questions, and these are very important questions. So I will explain everything one by one. Don't worry about this, just prepare yourself for the exams, and hope I will meet soon in the next lecture. Stay tuned, stay happy, and stay safe. Okay.